All right, I'm covering 6-4 today, which is factoring of polynomials. So we're going to do three things. Use the factor theorem to determine factors of polynomial, factor polynomials by grouping, and then factor the sum and difference of two cubes, and we have special rules to help us with that. All right, so let's look at the factor theorem first. So it says for any polynomial p of x, x minus a is a factor of p of x if and only if p of a is equal to 0. So what does that mean? It says if you substitute this value in to the polynomial for x and evaluate, if it's a factor, then you're going to get 0 for your answer. In the example they have here, x squared minus 1 is your polynomial. We want to know if x minus 1 is a factor, so we're going to take a, which is 1, plug it in to this polynomial here, and when we evaluate x equal 1, we see that it's 0. So that means that x minus 1 is a factor. So we are going to actually use synthetic substitution to help us with this. Determine whether the given binomial is a factor of the polynomial. So I've got two examples. I'm going to start with a, x plus 1 and x squared minus 3x plus 1. So we want to know, is this a factor of this? If we look at the factor theorem, we see that a is our 1, or more accurately, it's our negative 1. So a is this value here, but it's x minus a, so since this is a plus 1, that's why we want to find p of negative 1. We're going to use synthetic, it's actually called synthetic substitution, which we learned last time. So we have our negative 1. We pull down our coefficients, so 1, negative 3, 1. Pull down our 1. Negative 1 times 1 is negative 1. Negative 3 and negative 1 is negative 4. Negative 1 times negative 4 is 4, and this becomes 5. This means we have a remainder of 5, so that means that this is not a polynomial, or it is not a factor of that polynomial. Here's our second example, x plus 2. And here's our polynomial that we want to see whether it's a divisor of. So again, since this is a plus 2, our a is going to be equal to negative 2. Use our synthetic substitution. So pull down our 3. Negative 2 times 3 is negative 6. 6 and negative 6 is 0. Negative 2 times 0 is 0. 0 and 0 is 0. Negative 2 times 0 is 0. And this becomes 5. Negative 2 and negative 5 is 10. And we have a remainder of 0. So we know, without actually doing division, that this is a factor of that polynomial. All right, so you're going to try one next. You determine whether this is a factor of the polynomial by synthetic substitution, and we will go over this in class. All right, now we're going to start with factoring. We can factor polynomials by grouping. So here's the example. If I asked you to factor this right now, you'd probably have trouble with it. So we're going to group this into two groups. Since we have an even number of terms, which is 4, we're going to group it into this group and this group. So notice we've grouped the terms. We basically cut it in half. We can probably factor both of these terms. So we can see here we have a GCF, or greatest common factor, of x squared on this one. Write that down. GCF x squared. And here we can factor a negative 25 out of both of these. So a GCF of negative 25. So I factor the x squared out, and that leaves me with x from the x cubed and a negative 1 from the x squared. When I factor negative 25 out of negative 25x, I'm left with a positive x. When I factor negative 25 out of positive 25, I have a negative 1. So something you should see is we have x squared and a negative 25, but notice what we have. We've got the same factor here twice. So basically, we're going to do a greatest common factor. We're going to factor negative, or x minus 1 out of both of these terms. So I pull that out in front. When I factor x minus 1 out from this first expression, I'm left with x squared. When I factor it out from the second expression, I'm left with negative 25. And now I've factored this into two factors. And then the last thing we should notice is this is the difference of two squares. So this one is the difference, let me get this, of two squares. If I take the square root of x squared, I get x. When I take the square root of 25, I get 5. And if we remember, the square root a squared minus b squared always factors into a plus b times a minus b. So we can factor this into x minus 5 and x plus 5. And now we are done with our factoring. So it all started by grouping it, splitting it in half, factoring out what I could from each of those halves, and then I end up with a common term. So just a little tip, often you're going to end up with a minus here that you're going to want to pull into this second group so you can factor out the negative right there. So I think most of the factor by grouping have you do that, have you deal with this negative right here. So just be careful. This is the one that you should try, and you can ask any questions next time when I see you. All right, so now we're going to look at our final method of factoring. It's the sum of two cubes, and it's like the difference of squares, but it's a little more complicated. Of course, we're dealing with cubes. So this is the sum. The sum of cubes is always factors into this. So you're going to identify your a and b again, and it's going to equal a plus b times a squared minus ab plus b squared. The difference is almost identical, except notice the difference. Instead of having an a plus b, I have an a minus b. And instead of having a minus ab here, I have a plus ab. Other than that, they're exactly the same, which could be a good thing or it could be a bad thing. It could make it more confusing, or it may make it easier to remember. So let's look at an example. 4x squared plus 108x. First thing you want to do is always check, remember, always check for a greatest common factor. And in this case, we can see, at least we know we can factor an x out. What else can we factor out? Well, it turns out that they're both divisible by 4. So when I divide out the 4x, remember you pull that out front, and that leaves me with x cubed here, and this is 27. Now notice we have, this is a perfect cube and this is a perfect cube, so x cubed is a perfect cube, 27 is a perfect cube. We want to find basically the cube root of the first term and the cube root of the second term, so we can plug it into our formula. So the cube root of x cubed is just going to be x, the cube root of 27 is going to be 3. So this is our a and this is our b, and now we're going to use the formula for the difference of cubes. It's going to be a plus b. So that's x plus 3 times a squared, which is x squared, minus ab plus b squared. And our ab is going to be x times 3. So when we simplify, we get 4x times x plus 3 times x squared plus 3x plus 9. Let's see, are we done with that then? I think that's as far as it can be simplified. This cannot be factored anymore. Okay, but sometimes this can be factored, and you should just keep factoring until you can't anymore. Second example, 125d cubed minus 8. So So we look for a GCF. We look for a GCF, and there is none. So, but this is a difference of cubes. The cube root of 125d cubed actually turns out to be 5d, and that's going to be our a. And then the cube root of 8 is equal to 2, and that's going to be our b. So it's going to be the same thing. It's going to be a, except we use, this changes to a minus b, so 5d minus 2. This is AB squared plus AB plus B squared. Don't forget when you square, you're going to square the 5 and the d here. So you end up with 5d minus 2. This is 5d squared, so it's going to be 25d squared. 2 times 5 is 10, plus 10d plus 4. And basically, you're done once you get there. So it's just a matter of determining what your a and b are and plugging it into the right formula. So I would like you to try this one. Make sure you ask questions. And don't forget, you want to do GCF first before you use the sum or difference formula. All right, that concludes 6-4. Here is the homework. And bring questions. I will see you in class.